Continue. So what we've looked at so far, so we have two types of function. The function without parameters. Usually these functions do something. So they add to some list, for example, or they print something, or do something that doesn't require any arguments or starting parameters to work for this function. So other type of function is function with parameters. So basically, let's say we're looking for the same square area. So we can't find the square area without knowing two sides of the square or rectangle. So it depends on what you want to achieve, because some methods, as you saw before, some methods do get parameters and some methods don't. For example, there was a method print that worked without any parameters, but it had some parameters like separator and like what we finish the print statement with. So basically, depending on your task, depending on what you want to achieve, you can choose between should you have parameter and how many of those, or shouldn't you. Same thing with return. So not every function must return something, because for example, if we have a function, let's create another one, uh, def say hello. So we can actually create a function that prints hello and call it say hello. Say hello. So what does this function do? It actually prints the hello to the console, and that's it. So does this function need any parameters? No, it doesn't, because it doesn't use any parameters inside. But if we want to say uh, make this function say hello to some person, we can actually add, let's say, name inside here. So this function will accept one argument, name, and what it will do, it will say f return a hello name statement. So it will use the name we provided. And now if I run it like that, I will still get an error because I'm missing one positional argument, name, because I didn't enter it. Let's say Jack. So this function will run and say hello Jack, but exactly the same function can say hello to many different people.
Question.
Yep.
Can I write input
Inside function? Yes, yes.
inside
Pretty
say
much
hello?
everything you can write in normal Python, let's say in Python document, can be inside the function. So what you need to understand, that function is only a wrapper for some part of Python code. And usually it is used for the code you want to reuse. So because in programming it's a good approach when you create a variable if you understand that you use some value more than once. So for example, you use let's say you have variable x equals to 5 and you use it 2 times in your equation. It's better to create a variable. If you use it once, you can write it without any variables, just write 5. Can I see what type of error it gives? So right type error, argument name. You can't, it's not like that. You don't, if you want, let's say, I'll do the example. I'll do def say, let's name it, say hi, and it won't take any argument. But you want to ask person for his name before you do. So you can say name equals input like that, like you normally do. Enter name, and then let's say print hi name, like that. So you can actually use inputs too, and you can use everything you have in the regular Python inside functions. So you can use cycles, you can use if-else if constructions, and so on and so on. So if I use this one, say hi, it doesn't require any arguments, but it will ask for name. A bit later today, I will explain why this is not the best way of doing it. So let's sum up. Uh, Beginning from declaring a function. So when you declare a function, it can be without parameters or it can be with parameters. Actually, this number of different parameters is not limited, so you can use as much as you want. But it's a good way, it's a good thing to use 3, maybe 4 max. But I will show how to get over it. The return thing basically means that in the end of function's work, it will get the value of whatever it returns. And if you don't have any return, like for example, this say hello, so the execution of this function will be equal to none. So if you have return, the whole function will be equal to whatever it returns, including data type. And when you don't have any return, so function will be equal to zero, to none. What does it mean for us? So basically, if you want your function to do something, then get the answer, and you want to use this answer later on in your program, your function must return. So for example here, square area. So what does this function do? It actually finds us an area of a square by using width and height, and it returns the result, the area. So I might want to use this area somewhere else in my program. For example, for counting how much material I need to create something or whatever. So in this example, return is a must because I want to use this area later on in my program. But when function, for example, says hello or something like that, it just prints some message. Do I need to save this message somewhere? No, I don't. I don't want to reuse it. And in any case, if I want to get this message again, I can also call this function again. So I don't need any return statements here because I'm not doing anything with the result of what this function do. So it's up to you whether the function will have return or won't have return. But what you need to understand that function is equal to whatever it returns, or if it doesn't return, it is equal to none. So it's up to you. Um, okay, let's do something more complex. Um, What else can we do with functions? So I will comment everything out and continue here. There. Uh, so functions actually. Mhm. All right. So functions actually can work with variables outside of functions and inside of functions, and these are called global and local scopes. So what do I mean by that? For example, I say that A is equal to 1, B is equal to 2, C is equal to 3. And then I will create a function, def, I don't know, something. It won't be taking any parameters, but it will declare same variables inside it, but with different values. And I will print ABC here and will print ABC outside of the function. So basically inside and outside is shown by these 4 spaces here. Indentation here. And let's add something like local. I'll do it like that: local and global. ah, in order to run local, I need to run function as well. So,
Mm.
so these here are called scopes of visibility, and everything inside the function is a local scope of visibility, and everything outside this function is a global scope of visibility. So global is pretty much anywhere in your code, like you used to declare variables before today, before functions. Local is variables declared inside the function. So basically what I did here, I declared three variables in a global scope, and I declared three variables in a local scope. So when I run print inside the function, I'm using local scope variables. So I'm using these declared inside the function. But if I'm outside, I will always be using global scope variables. Why is that? It's all because of the logics inside the Python. So I will delete one of the variables, delete C declared in function. And what you can actually mention that we don't get an error here by calling C. So we don't get an error by calling C, and what will happen now?
It will take from the global.
It will take from global scope. So what you need to understand is the steps that Python does for looking for variables. So when we ask something in local scope, what actually Python does, it first of all checks if it has a local scope variable with this name. So for example, A is declared inside. So for A, it takes the local scope variable. B is declared inside as well. So for B, it takes local scope. And C is not declared inside the function. So what Python does, it looks if there is C inside, so in local scope. If it's not, Python will look in global scope then. But if it is, it will always take the local one. But if we speak about that bit, calling variables from global scope, I will return this C equal to 30 and delete C equals to 3. What I can see now, that without even running the code, I get an error here, unresolved reference C. So if I run this code, I will get a name error and I will get message that C is not defined. And the reason for that is that local visibility scope is never visible outside. So whatever I do in a global scope here, I can't address variables that are declared inside local scope. So calling for variables here will always use global scope only. And if we don't have this C declared in global scope, I will get error. But local scope can actually take both local variables and global variables respectively. So what you need to understand is that you must be very pay a lot of attention to where the variable is declared, because if you want to use it outside the function, you must declare it outside the function. One more example. I will take all of these declarations and put them here. Do you think it will still work?
Yes.
So I have function defined, then variables. It will. The reason for that is while you declare a function, it doesn't use variables. It's only declaration. We say we have a function that does that code or runs that code. But you need to declare these variables. For us, it's variable C that is used inside the function. You need to declare these variables before running the function, not before declaring a function. And this is why in Python, all functions, well, it's not a must, but it is recommended that you declare all functions on top of your document, on top of your Python file, because these are just declarations. They won't be executed and they won't cause any errors before you call the function. But if I put function call here, so I declare a function, then call it, and then declare variables in the global scope, I will get error. And why is that? Because here, when I'm trying to run this function, what happens? It actually Python runs this code. So Python declares A, declares B, and tries to print this message. And it sees that A, B, and C doesn't exist. Why is that? Because we declare C later. So if I run function before declaring this variable, it will cause error. But if I run it afterwards and declare before, there won't be any errors. So that's why in Python it is recommended to create all functions on top of your document and then call it later on when needed. So this is local and global scope. So summing up, I would say that if we speak about local scope, then logic is like that. So function is looking for variables in its local scope. If there is no variable needed, then it will look in global scope. Working backwards, you can never address local scope variables from outside of the function. And this is why I call functions a black box, because they cannot be accessed from outside. You can only call function, give it parameters, and get whatever it returns. Or get the result of whatever it does, if we say about functions that print something. Any questions on this part? Okay, I'll give you another example. Um, I'll give you another example. Let's say I'll do names, that is an empty list. And I'll do, let's say, number, that is equal to 1 first of all. And I'll create a function, def add name. And let's say it will take one argument, name. So what I want to do, I want to write a function that accepts a name as an argument and appends this name to a names list. Yep. So what I can do here, I say names dot append name. That's pretty much it.
So basically, the functions are the
Wrappers.
normal codes which
Yeah.
you are calling every time.
Yeah, it's just the logic is easy. So if you use same code more than once, it's better to put it inside the function.
Mm-hmm.
So you can reuse the function with a short name and you don't have to write a lot of code.
Mm-hmm. It's like variables, but big.
Yeah, that big variables that store parts of code inside. So if I try to run this, add name, let's say Jack, and definitely print names after that, we will see that it works fine. So what happens here? I told you before that lists are mutable. So this means that we can actually access lists from functions and add something in there. We can also remove something from list and so on and so on. Let's say I want to add more people. So I will add Mary, I will add Sarah, I will add Bob, and all of that will work. So functions can work with lists easily, access lists, create new new variables, and so on and so on. So new elements of the list. Okay, so what happens here? Our function addresses global variable names and appends some values to it. All of that is possible because list is mutable. So what we have here, we still have the same list, or actually, if you remember, we store link to a list, not list itself. But if we speak about simple data types, you remember that to copy a list, you need to use a copy method. Otherwise, you will have two variables with the same list inside. Remember that from the list lesson. So you also remember that we don't need to use copy for numbers, for example, or for strings, because we can copy one string, one variable to another variable, if it's string, integer, float, and so on. So what will happen if I want to say number plus equals 1? So what I do here, I want to increment my number by 1 every time I run this function. And if I run that, cannot access local variable number where it is not associated with a value. So the problem with simple data types is that you can't actually access global variables like that. You can read global variables, so you can get the value of the global variable without any problem, because if I say do print number here, it will first yeah, if I do it like that, if I print number, it will print the variable. So you can read these variables. But if you want to assign a new value to these variables, so basically using equal sign, and it doesn't matter which one you use, plus equals, minus equals. So if you want to assign a new value, and we know that this plus equals is the same thing as number plus 1. So we are assigning a new value. We're not changing the existing one actually, like we did with the list, because we have a method to add something to the list. But we are assigning a new value here, even with this plus equals. We need to declare this variable as global. So if it's a global variable and number is out there, in order to make our function be able to change this variable or to assign a new value, we need to say global number and everything will work. Let's say we print number in the end. Print number. What happens here? So we're actually saying this function, telling this function that number is a variable from global scope and you can use it. So this function now takes variable number that is declared in outer scope and changes its value. And from now on, if I say number is equal to minus 10, for example, this line of code won't be creating a local bound variable. Why? Because we told function that number is a global one. So we're skipping the step of local variable search. So after we say global to some variable, this means that Python will always be looking for a global variable, not a local instance of one. So just to sum up, if you want to change some global variable from outer scope inside the function, you need to address it. It doesn't work with lists like that, but also, for example, if you want, let's say, if you want to create a new list here, yeah, I'll do names equals to that. Yeah, like that. It will declare a new variable, local bound variable. So if you want to add names as a global one, you can add it here as well. Yep, names. So the difference is that if I print, no, leave it the same way, names, global number. Let's leave this names local variable. Yeah, it now looks as local variable. Yeah. So careful with those. If you need to change some variable inside the function, you better do it. You must add global here. Actually, if we speak about Python, it is not recommended to change global variables from functions. So it is always a better solution if you provide a function with a copy of a global variable and, let's say, do some changes to a copy and return a uh, let's say, changed copy of the original value. But sometimes we do need to address global variables, so don't forget, if you want to make 100% sure that we're talking about global variable, not local instance of one, add this global and a variable name on top of your function. Any questions so far? All right. So, what can we do with functions? Let's speak about different types of parameters inside functions, and then we will do some examples of how functions can work with each other. So, one more thing, two more things actually. One is different types of parameters, and second thing is functions called within functions. So let's speak about parameters now. So I will declare a function. Let's say, I don't know, sample. It doesn't matter actually. So what you've learned so far is that you can create some parameters inside functions. For example, a b, print a b. So function sample, let's say a will be equal to 1, b will be equal to 2. If someone wonders, can you use variables inside? Yes, you can. Yeah, so you just put the value of the variable. So if you have some variable here, you can pass it to function as well. So what happens here? You have two arguments that must be entered. Because if I skip one, let's say I leave just one, I will get error because of the missing required positional argument b. So when you create a function and provide parameters this way, a, b, c, whatever, yeah, different names. These names are used on the side only, so it's up to you how you call them. We are creating required positional arguments. But at some points, like for example with this print method, so if we look at print, it does have parameter separator, it does have parameter end, it does have file, it does have, and that's it. Yeah, so string, separator, end, and file. Have we ever entered these parameters? Yeah, we did with separator and end. But if I say like that, hello world, did I enter any other parameters? Do I enter separators? Do I enter end here? No, I only add the first parameter, the value that must be printed. So why it doesn't say that I'm missing required positional arguments? It is because you can have default argument values inside your function. For example, I want to say that C is equal to 1, or let's say equal to 0. I can do that inside functions declaration. So what will happen now? If I will run this code, sample 1, 2, let's say C as well. So if I run this code, I have to provide only two positional arguments, A and B, because A and B doesn't have any default values. But speaking of C, C has the default value. C is equal to 0. So every time I try to print C inside my function, it will print C. But I can also provide three arguments to calling this function, to this function call. 1, 2, 10. And what happens in this case? C is provided with a new value. So basically what we did here was said that A and B are required positional arguments. So you must enter them calling the function. And C has a default value of 0. So if you want, you can provide C like that. Or if you don't, you can leave it empty and then 0 will be used. So we can do arguments with default values. And if I come back to print statement and I look here, I see that values object has no default value. So you need to provide something inside the print. Separator has default value of none. End has default value of none. It definitely has some logics inside. If sep is none, then add a line break or something like that. Yeah, but separator default is none, and default is none, file default is none, flush default is some boolean, but it's optional as well. So you can add this C parameter if you want to use it, or you cannot. For example, I'm doing like that, plus. So A plus B plus C. If I don't provide C, I will only have A plus B summed. And C is equal to 0, so whatever we get in return plus 0 is equals to the same value. But if I add C here, like that, I will use C in there as well. So you can have parameters with default values. The general rule is that you never declare default value parameters before your required ones. You can see that we have a mistake here. So what you need to do is, first of all, you write your required arguments, and after that you can write default value arguments, and you have as much as you want here. For example, d equals 10, e equals 20, and so on and so on and so on. So you can have as much as you want, but the rule is that you first of all write required positional arguments, and after that you do default positional arguments. Second thing, you may not have any required arguments, for example like that. So your function might have several different parameters that all have a default value. This is possible as well. So pretty much you don't add anything, it's one behavior, you add some of the variables, it's a different behavior. So you can actually work with that as well. I will return like it was before. So required and default value parameters. We also spoke about how many parameters should I add. So it is, let's say it's not compulsory, but it is recommended that you don't use more than 4 parameters in your function. So what if I have more? We have different ways of creating it. First of all, you can provide, for example, list instead of a. So you can actually, let's say, I will go down here. Def person data. So you might have some data, and that's it. So you use it like that, and then here you will have data 0, surname is equals to data 1, and let's say age is equals to data 2. So actually you can create a function that takes only one parameter, that is a list, for example, with 3 different values. And let's say we will print hello. Oh, sorry. Uh, hello, name, surname. I won't be doing anything with H, but you get the idea, I guess. So I say person data and provide it with the list. Jack Smith 25. So I can actually give some complex data types to parameters as an argument and use it inside the function. This is one way of doing that. So you can say Jack Smith. What you need to understand that I provide a list for only one argument. Data is equal to this list, and afterwards inside my function I index data to get different parts of it. It's one way to get over this 3 to 4 parameters rule. Second thing, it's a bit complex, but I think you will understand it. Let's say person data is equals to, let's say we have a name as a required positional argument. And then we don't know how many different things will be provided. It's not the best example with person data. Let's say like that. Def sum many numbers. Yep. So num1, num2, and I want as many numbers as possible. So I want my function to work with minimum 2 values and maximum infinite values. So I don't know how many values will be provided, but all of the numbers provided must be summed and return a result. So result will be, for now, result num1 plus num2. Uh, let's say result equals and return result. So if I do it like that, how many numbers? 20, 30, it will return me, this function returns, I need to add its call inside the print. So what I want to do is to extend this function so it will accept as many arguments as I provide. So for example, like that, I will give some, I don't know, infinite number of mistake, like that. Yep. So for example, I want my function to work like that. I provide some, I don't know, unlimited amount of numbers, and I want all of them to be summed. So what should I do? There is an, let's do it like that, asterisk args. You can actually change this word args to anything you want, but it's usually used like that, args. So what is args? Print args. You don't need to use asterisks inside. I will show you this function call. So what we see here, args is a tuple beginning from 2 and a lot of different numbers. So what's that? I have num1 and num2 as required positional arguments. So first number I provide to this function is a num1. Second number I provide is a num2. And everything else I provide goes to args tuple. So basically args with this asterisk, it collects all of the data I provide in this function. So if I want to use it and say count everything, I can say for num in args result plus equals num. So what my function does now, it takes any amount of numbers, sums them all, and add it to the result variable that is returned in the end. And you can give as many as you want. So basically this is num1, this is num2, and the rest of them all go to args. Why do we have an asterisk here? It's easy. Let's show example here below. X is equal to 1, 2, 3. Y is equal to, let's say, 10, 20, 30. And I want to say print Y. So what I want to do, I want, for example, I want X to be here somewhere. So what I can do it like that. And star is a destructurizing operator for lists. So what happens here? I say star x. This means that Python will destructurize this list for its members, 1, 2, 3, and add them all into this list. So in the end, I get that. Quite interesting. We could use this with tuples. Let's see. Will it work with tuples?
We could use this
In a test. Yeah, I think so. So we could use this as well. It's destructurizing. So basically what happens here when you put X with a star, it actually, well, let's say, does the for cycle itself. So adds each of them here. So that's why it works here, because args is nothing but an iterable. So you can do actually add iterable like that. Destructurizing. So you can use args to make function accept as many variables as possible, and later on we will see methods that use args. For example, we will have method that accepts as many iterable objects as you provide and combine them in one. So this will be in, I don't know, maybe 3-4 different lessons. Right, but that's not it. You can actually add another thing here, two asterisks, key w args. So key w args stand for keyword arguments, and keyword arguments. And let's print quarks here, and I will show you how we can add it. So actually, if I run it like that, you can see that kwargs is nothing but a dictionary, empty dictionary. Why do you think I know it's empty dictionary and not a set?
It doesn't work for me.
I want to check. Yes, there's mistakes. There are mistakes inside the function as well. Result equals so many numbers, and there's a mistake here, many. Yep. And you don't need to space in front of the brackets as well. It should work now, but print quarks as well so you can see. And you need to print quarks like I have somewhere inside the function. So what I have here is a dictionary. Why do you think I'm sure it's a dictionary, not a set? Because they share these brackets. Any ideas? Because you can't declare empty set with only these brackets. Empty set, every time we create, let's say, print type of that, we declare a dictionary. It's never a set. So that's why it's I'm sure. So what happens here? Keyword arguments creates a dictionary inside your function, and it works like that. So pretty much it doesn't matter how many different arguments I provide here, all of these are args. And if you want to provide quarks, you can provide them like that. Check surname Smith, and so on and so on. So if I provide a keyword with a value, it will automatically go to keyword arguments, quarks.
So keyword argument is always dictionary.
Yeah. Because we have keywords, yeah. So keywords and the value parse, key value parse, keyword argument. So if you want to provide something to quarks, you can do it like that by providing a name, a key, and a value after equal sign, and it all will be added to this keyword arguments
In
dictionary.
future, we can add JSONs.
Yep,
Yeah.
yep. In Python, after you get the JSON, you will convert it to dictionary and work like with a normal dictionary. So JSON in Python, JSON is similar. It is called object in JavaScript. So JSON comes from JavaScript object notation. So pretty much JSON is a copy of JavaScript objects that is very similar to Python dictionary. That's why when you convert JSON to Python, you will get a dictionary in return. Right, so as many arguments as you want. And actually, you can provide these too. So you can actually say num2 equals 20 and num1 equals 30. You can do that, but you will get a mistake using args then. So if you're using args, don't do that. But if I, for example, delete args from here and delete args from here, and then I delete all of them from here as well. Did you mention what I made? I made num2 as a first value and num1 as the second value. So if you provide these required arguments keys here, you can actually change the order of the values as well. Right? But if you don't understand arguments and keyword arguments now, no worries. You won't need it in the, like, let's say, next couple of lessons, and I will get back to them when we need it. Last thing, and we'll do some exercise. So last thing, functions can execute other functions. What I mean by that, I can say that, let's say, def def area a b return a times b. Def, let's say, perimeter a b return a b, a plus b times 2 times 2. Def count. So for example, I'm creating carpets, square shaped carpets. And what I need to know is how much material I will be using. And I have area and perimeter because area is the material the carpet made of, and perimeter is another material that goes on the edges around the carpet. So I want to count materials, and I created separate function area and separate function perimeter to get the sizes of these carpets. And I do a third function, count material, that will actually do the counting for me. So what I want to know, amount is how many carpets we made. A and B is the length, width and height of the carpet, or length and width, or whatever. So the sides. So what I do here, I say that, let's say, area material will be equal to area AB times amount. Let's say edge material will be equal to perimeter AB times amount. And let's say return, let it be a dictionary. So area, say total area will be area material, and total edge will be edge material. So I want 10 carpets and their sides will be 20 by 40. So what do I get in return? Let's say we speak about centimeters or whatever. So what happens here? My count material function actually calls other two functions in order to get the results. So what I have here, amount is how many carpets I want to create. A and B are both sides of the carpet. So what happens here? I give A and B to my area function, and I get the area of one carpet. And then by multiplying with amount, I get the total amount of material for the carpet making. Same here with perimeter. So you can actually call functions from other functions. It is normal in Python. So basically, if we say we take the same ID code task for home and split it in different functions, so we will have a ask ID function that will ask for your number and save it somewhere. We will have a menu function or main function, call it whatever you want. Then we will have a gender finding function that will accept a number or ID code and find the gender for you. Date of birth function, validation function. So we can split this work in different functions. And our main menu by user entering some number in main menu will be calling just different functions to execute pieces of code. So you can actually try this at home if you want. So you can use other functions as well. I'm not showing you, there is more actually. You can make function as an argument and call functions inside. I'm not showing you that because it's quite, let's say, quite challenging task. But what I want to do with you now, let's create a quiz game. Let's create a small quiz game that will ask questions, get answers. I will call it a quiz. And before we start, let's create questions. So I create a quiz variable that will be a dictionary. Let's quickly do 3 questions. So I make a key question 1 that will be also a dictionary. And inside I want to write a couple of things down. First of all, question. What color the sky is. Then we have answers. So all possible answers. Let's say red, green, blue, yellow, and the correct answer. The correct answer will be blue for us. And I'll copy that. I'll copy it 3 times. Just make a couple of questions. I will make question 2. What color, let's say, the sun is? And the right answer will be yellow. And let's say 3. What color the, let's say, grass is? And the right answer will be green. So for now, I'm doing this dictionary with questions, possible answers, and the correct answer I will be using later on. Mhm.
Yes.
Is everyone done? Look, create at least one question. So you can add more questions if you want later, because we will be writing a program that will actually work with as many questions as you want. So what we will be doing here, we will write 3 functions. Uh, we will write 3 functions. First function will be the function to ask questions. And if we speak about functions, it's a great rule for yourself if you do it this way. One function must do one task. So basically, one function executes one task. That's a great way of planning your project. So let's say we do a function that will ask questions. We'll do a function that will get answers. And we also will do a general, let's say, main or play function that will call both of the previous ones. So let's do it like that. So def ask question. Ask question. By asking question, we actually need function to get this bit. So basically the question itself. Yeah, so we will be writing a for cycle later that will be taking different questions. But what we can actually do here, so our function will need to receive a question as an argument. So it needs to know what question it asks. And why am I doing a function? So later on you can add, I don't know, 100 different questions. And if they are all of the same view, like question, answers, correct answer keys, our program will work with any questions you ask. So let's say here we provide the question, some question. And by meaning a question, I will be using that. So I will be providing the whole dictionary to my function and it will extract only question from here. So let's say I'll name it q, just the q, so we won't have similar names. Next thing, I need to print question itself and also give possible answers with numbers. So 1, 2, 3, 4. So choose an answer. So printing question is easy. Print q question. And bless you. And once again, by this q, I mean whole dictionary with the question. So I will be providing these dictionaries in that function as a q. So in order to print the question itself, I can address q and ask for question key.
Not Q1, but Q.
Q.
Okay. Okay. Okay.
Q. So I will be providing all of them. So this function will take all of the questions and ask one question, then another, get the answers. So how can I print all of these answers with numbers in front of them? So let's first of all, let's see what answers is. It's a list. So if it's a list and I need to print every single element of list, I must use a for cycle, but I will be using it differently. So I won't be using for cycle like for, let's say, value in answers or something like that. I will be using for I in range 4. What that will give me? It will give me indexes. So we know that if I put one number inside range, it will be range from 0 to that number not included. So for us, for I in range 4 will mean range from 0 to 3 included. And these are actually indexes of these colors. So 0, 1, 2, 3. So I will be using this logic. Why is that? Because I want to use the same I to provide numbers. And we will have different numbers because 0, 1, 2, 3 are indexes, but we want user to enter 1, 2, 3, 4 for the correct answer. Okay, so how can we do this? We can print inside. I will use f string. Like that. I plus 1, because I want a bigger number. And q answers. Let's do answers. And I want to index answers with the same I thing. So let's test it. Yeah, you can use I, for example. We can use I as well, but then we will give. I'll show you the difference now. So I will do ask questions and provide quiz Q1. Let's see, let's do it like that. So this is how the question asking will look like. So ask questions, Q1, let's say Q2, what color the sun is, Q3, what color the grass is, and so on and so on. So we managed to do that. So why I was using this I plus 1 logics? Because if I leave just I here and do that, we will have the same as indexes, 0, 1, 2, 3. And if we speak about quiz, we don't usually ask choose an answer from 0 to 3. Yeah, which will say choose an answer from 0 to 1 or from 1 to 4. So I will add this plus 1 here, so we will have this correct way of asking questions. So this function is pretty much done. We can reuse it with any question, just provide question and call the function. and it will ask questions without any problems. I will delete this function call and come back in beginning. Def. So next one will be asking user to enter the number and checking if the number is allowed. So basically, we have numbers from 1 till 4. If user picks something else, we need to ask him to try again because the answer was out of range. So let's say get answer. Uh, as I told you before, we want user to keep entering until he enters a legal number from 1 to 4. What we will use it here? What Python construction we will use here? While, because we need to rerun the code if something is wrong. So I will do the while true thing. So let's ask user for his answer. So user answer is equals to input your answer. And here I need to check something. So what I need to do here, I need if user answer, and I will do not here. Here we need to check if he entered from 1 to till 4 is in. Yep. So I will do not is in but in, just in, and I can do it like that.
Not range.
Can you use range?
We get string from input. Range works with integers. So in order to use range, we need to convert user answer to integer and then use range. But here we can use it as a string. Actually, Erwin, you asked about homework for that's the second way of checking it. So not in range, for example, by converting each number, but you can check in string for like that. So basically, if user enters 1, it will work. But also it will work if user enters 12, for example, for here. That's why I'm doing it a little bit differently. I will put a list here. 2, 3, 4. So why list? Because if I leave string here, user can enter 12, for example, or 1, 2, 3, 4. 1, 2, 3, 4 is in 1, 2, 3, 4 string. But if user enters 12 and we check the list, it won't be inside it. So what we do here, I will return the user answer. And I didn't tell you before, but every time you get to return inside the function stops working. So basically, if you have reached return, function returns and stops executing the rest of the code. So I don't need any break here to quit this while true cycle, because as soon as I get to return, the function will stop working itself, including the cycle inside it. So else print try again. We don't need any else, because if we get here, return will be executed and we will never reach that bit. If we don't get here, we will just print try again and start over. You can put else if you want, but it's not needed. Right. Next will be we will be doing a, let's say, main function, or I will call it def play. Play doesn't need any arguments. And what I also want to do, I want to count user score. So I want to know how many right answers user gave. So I will do that in separate variable. I will go to the bottom here and say user score equals 0. User starts with score equal to 0. So no answers provided yet. And what I want to do is I will be changing this user score value inside our functions every time user gives the correct answer. So what do I need to do to change global variable inside the function? Yep. So I do global user score. Right. And what do I need to do here? I need to use for cycle for our quiz variable to get all of the questions and provide these questions through ask question and get answer function. So basically I will be using for, I get the first question, first dictionary, then use ask question to print all of the questions and possible answers, then use get answer to give user an opportunity to answer it, and then I can check if it's a right or wrong answer. So we will be using a for cycle for, let's say, question in quiz. Can I leave it like that, or I need to do something else?
No, you should check if the user answer and the correct answer is the
No,
same.
we don't have, we don't ask for answers yet. I'm just iterating quiz. So I want to get all of the dictionaries from it. So if I leave it like that for question in quiz, I will be iterating keys. So instead of question, I will get Q1, Q2, Q3, and so on. But I need not a key but a value here. So what I can use here, quiz dot values. So instead of getting this Q1, Q2, Q3, I will be getting the whole value. So actually the whole dictionary as a question inside here. So our function ask questions receives these dictionaries as an argument. So I can ask a question here. Ask question, question. Next thing, I need to get user's answer. So by asking ask question, I will print the question and possible choices. Now I need to get answer from user. So let's say answer is equal to get answer. We don't need to provide anything in get answer because get answer only asks for a number from user, and that's it. So next thing I will be doing this way. I will be extracting correct answer and comparing to what user answered. So I will say user answer is equal to question answers, because I'm not sure what user will say. We are getting that dictionary or that list from here. And if you remember, user is choosing numbers from 1 to 4. and we have indexes from 0 to 3 in this list. So in order to index, so question answers will return me these lists, and in order to get the right thing, I need to convert answer to integer and take one off. So basically whatever user says, like for example 4, I need to enter 3 instead, because 4 user thinks 4 is the last answer, and actually in Python last answer has index 3, not 4. And now I can compare. I can say if user answer is equal to question correct answer, then we can say that user score plus equals 1. You can actually do it differently. You can provide correct answer as the number, for example, and check if user entered the right number. So it's up to you. But so pretty much everything's done. So what we do here, let's say we call this play function, and let's print the result. So you answered. I will do it with a formatted strings. User score questions correctly. So let's try. What color the sky is? Your answer 3 blue. What color the sun is? 4 yellow. What color the grass is? 2 green. You answered 3 questions correctly. So let's try again. Sky red, sun green, grass blue. You answered 0 questions correctly. So our quiz actually works, and we can add as many questions as we want. If it's a four answer choice questions, they will work here as well. Now I expect you to ask me questions.
Where did you mark which answer is correct?
We do have it here, correct answer in each question.
Mhm.
That's why we, as a user answer, we actually get the answer from this list. So basically, if user, for example, says 4, we do 4 minus 1, 3, and take the last index here and save the answer. So later we can say user answer that we extract from this list and compare it to correct answer, that is a string with a color actually here. Any more questions? Does everything understandable at this point?
I should
Not
check
really.
it at home. It's not like it's understandable, but I should check everything one by one.
Yeah, yep.
Yeah, for example, we can try to print out the right answer, the wrong answer.
Yeah, you can modify it as much as you want. So it's just like one, well, let's say it's not the easiest way of creating quiz, but it's not complex too. So you can actually do a lot of different things here. But with this code, you can actually create as many questions as you want and create your own quiz and make it work. So what I want you to do at home, most of you didn't finish this ID code validator so far, so try to do that. Those of you who already did, you can try to split ID validator into functions. So basically do the same thing, but make it with functions. So every small part is a different functions. Uh, and I think that that should be enough. So we have another lesson on Friday. That should be enough for now. So data analysis part will continue with Nikolai learning analysis, and Python part will continue with me learning Python. So we will be working with files, looking at different libraries, and so on and so on. What I want you to think about is that we had 5 lessons so far. There was a lot of different topics and information moved quite quickly. So if you feel that you don't understand something or some parts of what we did is totally missed by you, just let me know that in advance so I can probably make some extra lesson for you just to revise some stuff or explain more, because these are just basics of Python that must be understood, because when we move forward, we will have some libraries, for example, that if you don't understand, you might never need it. Like libraries for parsing. Not every Python programmer will be doing parsing, or libraries for analysis. Not every Python programmer will be doing analysis. But these parts that we did now is very important to understand because it's basics of Python itself. So if you have any questions or if you feel like some topics are missed, please let me know so I can actually correct my program and maybe we do some exercising on some bits that are hard to understand. And yep, I will provide you with information about where data analysis lesson will be held on Friday, and then Nikolai will provide you with timetable and so on. Maybe he wants to change something, maybe not. We'll see. I can't comment on him. As a Python part, those who are assigned for a Python course, we will continue the same way. So it's Tuesday or Wednesday, Friday at 2, if that's okay with you. How many people was there? Three, I think.
No Mondays.
I can do Monday evenings now. I can do in 2, maybe 3 weeks.
Mm.
So we can switch to free lessons later on. I can do evenings actually, but I can do Mondays from 2 o'clock. But, let's do it this way. We will gather with Python part on Friday, and we can speak about that and decide. Because some people can do sometimes, so will gather with our smaller group, and then we will decide. Maybe we can do, because I am not against doing 3 times a week, but we need to choose time because I have this front end course Monday, Wednesday, Friday evenings. So I need to finish them as soon as possible. They will go to different teacher. Then I will have more spare time making more. But if we do, for example, one lesson on Tuesday or Thursday, or maybe do one lesson at 2 o'clock on Monday, so it's okay with me. But let's speak about that on Friday because we need to split and decide between each smaller group. So how we work then. Right. Any questions so far? Good. Then